It seems like, security teams are almost set up to fail these days.
Oh,
I
totally.
mean, the amount of data they have to deal with, it's just overwhelming.
Hmm.
Alerts, logs, you name it.
Right. And actually finding real threats in all of that noise. It's like trying to find a needle in a really, really big haystack.
A very digital haystack.
Yeah, exactly. And the old ways of doing things, they just don't cut it anymore.
Right.
We need something smarter, a way to figure out what actually matters and filter out the rest. Let those security pros focus on, what actually needs their attention.
Which is why today we're diving deep into energy-based models, EBMs.
EBMs, yeah.
And I gotta say, the idea is pretty clever.
Oh, it is.
Instead of hunting for known bad stuff, EBMs learn what normal looks like, for your systems.
Mm-hmm.
And they give everything a kind of energy score. Low energy for normal, high energy for anything suspicious.
Exactly. Basically, it's like the EBM builds a model of how your systems should be behaving. So
Yeah.
when something deviates from that, like it sticks out, it gets a high energy score, and boom, that's your potential issue.
Even if it's something brand new.
Even if it's something brand new, right?
A new type of threat.
Yeah.
So our goal today is to really dig into how these EBMs could actually change the game for security operations.
A whole landscape, yeah.
Can they actually help security teams detect threats better, respond to incidents faster, even manage vulnerabilities more effectively? That's what we want to find out.
And to really go deep, we've got some really cool material here. Like we're talking everything from, the fundamentals of EBMs to some cutting edge research on how they're being used in cybersecurity. Plus, we'll even touch on what it takes to actually put this tech into practice.
Okay, so let's unpack that core concept a bit more.
Yeah, let's do it.
Everything we've read really emphasizes this idea of learning through energy values. Higher the energy, the more likely it is an anomaly. And this feels very different from traditional security tools. Yeah, those often rely on recognizing patterns from past attacks.
That's the thing. They're always playing catch up. They need to see an attack before they can recognize it again. But attackers, they're smart.
Always evolving.
They're constantly coming up with new ways to do things. That's where EBMs have the edge because they define normal. So anything that doesn't fit that mold, even if it's brand new, boom, it's flagged. High energy.
And one of the really foundational works here is that paper by Jan LeCun.
Oh yeah, a tutorial on energy-based learning. It's a classic.
It really lays out like the mathematical foundation of all this. And he talks about how EBMs can handle all kinds of data, structured stuff like network logs, unstructured stuff like, text reports. It seems really relevant to, the real world of security data, which is just messy.
Oh, it's super messy. But that's the point, right? A real security incident, it leaves traces everywhere. Different systems, different formats. But an EBM can look at all of that, all that messy data, and give you one overall energy score.
A holistic view.
A much more holistic view of a potential threat, yeah.
And then there's Jeffrey Hinton's work on products of experts.
Ah, yes.
If I'm understanding this right, it's all about combining a bunch of simpler models, the experts, to build something more sophisticated.
It is. Imagine you have a whole team of specialists.
Right.
One's focused on network traffic, another one's looking at user activity, another's monitoring application performance. Each one is an expert EBM, and they each look at the energy level in their area.
And then they combine that.
Right. They combine those individual assessments to figure out the overall energy of the system, way more accurate at detecting anomalies that way.
So let's talk about how this is being used in the real world, because they get pretty interesting.
Oh, for sure.
There was this 2022 study in IE transactions on information forensics and security.
I remember that one.
They used EBMs to spot unusual activity in network traffic.
And the results. Pretty promising. Not only were the EBMs better at finding malicious traffic compared to, those traditional neural networks. Yeah, but they also had way fewer false alarms. It all comes back to, defining what should be happening on the network.
Then we saw that case study from RSA Conference 2023 using EBMs to automatically sort and prioritize security incidents. So they used those energy levels to figure out which incidents were the most critical.
Right, and that's the cool part. The energy score was directly linked to how serious the incident was.
Direct correlation.
Yeah. Think about it. Security teams can move away from just reacting to every alert as it pops up. Instead, they can go right to the source, the high energy stuff, the stuff that's actually the biggest threat.
Focus your resources.
Exactly.
And we even found examples in vulnerability management.
Oh, yeah.
There was a presentation at Black Hat 2024.
Love Black Hat.
about using EBMs to predict how likely a vulnerability is to actually be exploited.
Oh, that's a good one. Because, basic vulnerability scoring systems, they only get you so far.
Right.
But with EBMs, you can factor in things like, how attackers are actually behaving, the context of the vulnerability, and that gives you a much more accurate idea of whether it's going to be exploited. Helps prioritize patching, too.
So much more efficient.
Way more efficient.
And one last one that really blew my mind.
Yeah.
That IA Security and Privacy study from 2023. They were talking about visualizing cybersecurity risk as an energy landscape. Imagine like a map of your entire organization's security.
That's a powerful image.
Safe areas, low risk, low energy, and then boom, dangerous peaks, high risk, high energy.
It's so much more intuitive than just, a list of vulnerabilities or metrics.
For sure.
Executives can actually grasp the situation. Then you can have a real conversation, a strategic one, about where to invest to make things safer.
Lower the overall energy.
Exactly.
So it seems like the potential here across security operations is massive.
Massive is an understatement. It can spot those subtle anomalies in network traffic, give you a big picture view of risk. I mean, come on.
Okay, but let's get down to brass tacks here.
Let's do it.
What kind of setup do we actually need to get EBMs running in a real security environment? What's realistic here?
Good question.
Alex, I know you've been looking into this. What are the requirements?
So to train these models, especially on the data sets we're talking about in security, you need some serious horsepower. GPU power specifically, we're talking NVIDIA A100s, 3090s, that class of card to handle all the calculations.
It's not something you're going to run on your laptop.
Probably not for real training. You can experiment locally, just mess around with Python, PyTorch, maybe some Jupyter notebooks.
Right.
But if you've got a whole team working on this, you're going to want Docker to manage your environments, MLflow to keep track of everything, and DVC for versioning your data, the whole 9 yards.
What about actually using these models live to monitor for threats all the time?
Okay. For production, especially if you're dealing with streaming data, you need a much more robust infrastructure. Think Ray for distributed processing, Kubernetes to orchestrate it all, and Kafka to handle that constant flow of security data. And you might even want to push some of the anomaly detection work to the edge, put nodes closer to the source of the data, reduce latency, because we need to flag things fast in real time.
So high-end hardware, complex software.
The commitment, yeah.
Jordan, stepping into those executive shoes, what's the ROI on all this? I mean, can we really justify the cost of the infrastructure, the engineering time, all the ongoing expenses? It sounds like it could get expensive fast.
Well, that is the million-dollar question, isn't it?
It is.
But our sources do give us some numbers. They're saying ballpark, building a full EBM security system from scratch could take, I don't know, maybe 17 to 23 full-time equivalent months of engineering work. Then you've got your operational costs on top of that. Cloud infrastructure, software licenses, all that. They're estimating somewhere between $2,250 and $6,350 per month. Not exactly chump change.
So where are the concrete benefits here? What's the return on that investment?
Okay, so the ROI here, it's not just about saving money directly. It's about doing security better and more efficiently. If EBMs can drastically improve your threat detection, you're potentially avoiding some huge data breach costs.
Right. Prevention is key.
Exactly. Plus fewer false positives. That means your security analysts aren't wasting time chasing ghosts. They can focus on real risks. And then faster incident triage, more accurate vulnerability prioritization, that can save you a lot of money too.
So less downtime.
Less downtime, faster response times, and way more efficient patching.
So it's about making security spending smarter and avoiding bigger losses later.
Exactly. And let's not forget about automation.
Yes.
If you connect EBMs with SOAR platforms,
Yeah.
security orchestration and automation platforms, a lot of those routine incident response tasks can be automated.
Okay.
Less work for your security team, and they become even more efficient, which translates to real cost savings, fewer people needed.
This all sounds great for those big companies with mature security operations and, deep pockets. But Riley, I know you've been thinking about this from the perspective of a smaller company.
Oh, yeah, definitely.
Is this even realistic for them? Or is this just for the big players?
Right, because when I hear about needing all these fancy GPUs and super complicated software, I immediately think, okay, that's got to be way too expensive for a small or medium-sized business.
Right.
I mean, can a company with a small IT team and a limited budget even dream of doing this? Or are they stuck with the older, less advanced stuff? Like, how big do you actually need to be to even consider EBMs?
That's a great question, and it's important to consider those different levels. Going all in and building a custom EBM system like we've been describing,
Okay.
that's probably a lot for a smaller company to take on.
Right.
But there might be other ways to approach it.
Okay, like what?
Well, they could maybe focus on just one really important area, like protecting a critical application. And they could look at cloud-based AI services, offload some of that infrastructure burden.
And from a cost perspective, smaller companies really need to be strategic. Maybe start with a small pilot project.
Right.
Focus on one area where their security is the weakest. And they really need to figure out the total cost, not just the tech, but the expertise needed to set it up and manage it.
And don't forget, smaller companies can look at open source EBM frameworks and communities.
Good point.
That'll help reduce those initial software costs. The key is to figure out where EBMs will give them a real advantage over what they already have, and find a way to deploy them that fits their budget and their tech skills. It doesn't have to be all or nothing.
So start small, focus on a specific problem, and look at cloud services.
Exactly.
Makes sense.
So to sum it all up, what are the biggest strengths of EBMs that our listeners should take away from this deep dive?
All right, so number one, EBMs are a powerful way to find anomalies because they learn what normal behavior looks like. They're amazing at spotting new threats that are constantly changing.
Yeah, man.
Number two, they give you a way to actually measure uncertainty, which helps you make smarter, faster decisions about things like incident response and vulnerability management.
Makes sense.
And finally, being able to visualize risk as an energy landscape, that's huge. It makes understanding your security posture way more intuitive.
But it's not all sunshine and roses, is it? What are the challenges here? What should we be aware of?
Oh, absolutely. This is not a silver bullet. First off, the computing power you need, especially for training on massive data sets and doing real-time analysis, that can be a lot.
Right.
And EBMs, they live and die by the data they're trained on. It needs to be good quality and diverse.
Right.
And while some EBM setups are pretty easy to understand, some can be more of a black box.
So not always transparent.
Yeah, not always.
Yeah.
And that could be an issue if you need to be able to explain why a security decision was made.
So potentially revolutionary technology, but with some real-world considerations around cost, data, and transparency.
Exactly. And this brings us to a really important question for you, our listener.
Okay, hit us with it.
As cyber threats keep getting more sophisticated, and there are more of them all the time, how are organizations, big and small, going to balance adopting these advanced AI-driven solutions with their budget realities and the need for security measures that are clear and easy to understand? What new deployment strategies or hybrid approaches might we see that will make powerful tools like EBMs more accessible and trustworthy for everyone? It's a big challenge, but it's exciting, and it's going to shape the future of cybersecurity.
It is.
Yeah.
Well, on that note, we're going to wrap up this deep dive into energy-based models. So much to think about, so much to explore. Until next time.
See you then.